So, hello everyone. Good evening. Can you hear me?
Yes,
Yeah,
ma'am, you are on.
yes, ma'am.
All right, great. So, hello everyone, and welcome to the third live session. So for week 3 of Biostatistics course. So let's not wait any longer. I don't think more people are joining. It's already 6 o'clock. So I'll just start sharing my screen. Okay. Yeah, I think you can see my screen now. Right. Okay. So yeah, in case if there's anybody who's joined us for the live sessions for the first time, so this is what our schedule for these live sessions are. So there are 2 parallel sessions going on every Friday and Tuesdays, and you can join any one of them. And the videos for both of them are also available on YouTube. You have the link to a sheet wherein we have updated the links to the YouTube channel and the Google Drive, which has all the material that was discussed in these live sessions. Okay, so this is where we are today. We'll just discuss this. And so yeah, see the just the basic all the links for your reference. And let's start. So before we begin, do you have any questions? So again, for today's session, what I have planned is we'll just quickly revise what all topics were covered. We'll also have some practice questions, and we will discuss, depending on how much time we have left, we'll discuss at least some questions from week 1 and week 2 assignment. If we have time, we can discuss all of them also. So by the way, the solutions are available online. There's a PDF for both the weeks. So we can just quickly go through those, and if there's any confusion, we can discuss that in detail. All right? Okay. So if there's any doubt, you can ask now, otherwise I'll start. Okay. All right. So just continuing with where the topic ended in week 2. So something called covariance and correlation was discussed. So covariance is this formula wherein it's a mixture of finding out the variances of both of two variables, right? So if you remember the formula of variance, it's if x is the only variable, then xi minus mean of x, and then you take the square of it, you sum that up, and then you take out the root of it, right? You divide by n minus 1 and you take the root of it. So now so the changes here are, instead of taking a square, you are finding out the product of these two differences, and you don't find out the root. All right, because we are talking about two variables in this case. And as we discussed, the issue with covariance is, depending on what units x and y are in, the unit of covariance will also change. So it may not give you a great indication, and you cannot compare two different covariances. All right, instead, if somehow this thing is normalized, then it will give us a better picture of how the two variables are related. So in that case, something called a correlation coefficient is defined, wherein you multiply this covariance by the standard deviations of each of our actual variables. And it said that this coefficient of covariance, which is denoted by rho in this case, you may also come across this as Pearson's correlation coefficient. So this one has values between -1 and 1. So 1 means they have a positive correlation. When one increases, the other also increases. And the other thing is, if it's a negative correlation, when one increases, the other decreases. And values around 0 means that there is not much correlation. There's not much relation. They're both independent of each other. All right. So once, okay. So if there's not a question, you can unmute yourselves. All right. Yeah. Sorry. Just give me a second. Right. Okay. So now so one thing is, you would like to find that, okay, two things are related, two things are going in similar direction. When one changes, the other changes in so and so way. But now let's say if they are actually related, and if you would actually like to predict one from the other, because now you think that there's an equation that you can fit in between those two variables. So simple, imagine you have a 2D plot, and now you have one variable on the x-axis, one variable on the y-axis. You are expecting a linear trend, so you would like to predict one from the other, and it's just by nomenclature, so as to say that the one that you are going to predict is called the y variable, and the one that you have, it's that you already have the value of, that's called the x variable. All right, now let me just draw something here. All right, so now this is your x and y axis, right? And let's say we have this line that we have, so the line may pass through some points, the line may not pass through all the points. Okay, right? So now the way, there are two things in this that you would like to take care of. Let me change the color of the pens, one with black. So one is this vertical distance. All right. So the line is fit in such a way that this vertical distance is reduced. Now, another important thing that you would like to know is that if this was the actual line, then let's say this is, maybe this is not a great color, not clearly visible. So, okay, so maybe this is a point. So let's say for this value of x, the actual value you got, right? Let's say you are actually checking if this line is a good fit. So you know that this is the actual value of y. But what this line gave you, if you actually fitted this line, what this line gave you was this value of y, right? So this, let's say we call it yi. This is the actual y. And this value, let's say we just call it prime in this case, and this means the predicted value. So this difference is also something we would like to reduce as much. All right. So here for today's discussion, we'll focus more on this part to check once. So, okay, let's proceed and then you'll see. So yeah, so something like this. So you have the actual set of values on the x-axis, the actual y values, and if you fit a line, it is going to give you a list of y values, which may or may not be the same as the actual y values, right? So these are predicted y values, and often they are denoted with a prime in this case, but that's subject to which format is being changed. Okay, so now once that is there, how do we proceed about it? So this is this error that we are talking about, right? The ones I showed on the y-axis here. So we are interested in this. So this is for any given one point, the actual yi minus this is your predicted yi, because the line that you're trying to fit is, so it's a straight line. So you can either call it y is equal to mx plus c, or you can call y is equal to a plus bx. It's the same thing, right? So b is going to be your slope and a is going to be the y-intercept. So now, as was discussed in the course also, so some of this, so let's say if we are talking about the lines, we're talking about the points which are above this line. So here, let's say by our definition, yi minus the predicted value. So this is going to give us a positive error. And points like this, lower ones, are going to give us a negative error. So if, let's say, you have equal deviations on both sides, this error is going to become zero, but that's not true, right? So a better measure of error instead is that you're finding the square of this difference, and then you're summing that up, right? So we know that two most common and most often used ways of quantifying errors, they would either use an absolute symbol, or they would go for the square of that value, right? So now this becomes our error, and as we understand, we would like to reduce this error. So to reduce this error, we would, so one of the ways which is used in differentiation is that for any given value, for any given function, for any given plot or a curve, to find the minima and the maxima, a derivative is taken. right? So very simple example of you can take the example of velocity and acceleration and things like that. So right, let's say this is time and this is velocity. So if this is how velocity is going, so at these points the change in slope is 0, right? So these becomes your highest and minimum points of velocity. So now in this case, what is our variable? So x and y are known points. For this equation, we know what x is, what y I is. So in this case, a and b are our variables, right? So yeah, these are our variables. So what we would like to do is if we differentiate this error with respect to a and with respect to b, and we set that this differential has to be 0, we are going to get these two equations. I will not be discussing their derivations because this was already discussed in depth in the lectures. All right. So now if you solve this, one of them gives a slightly complicated view, but you can think of this in terms of, a very similar formula to what we said for correlation. Instead of y, like the standard deviation of y, here you just have the square of standard deviation of x. And so once one of the variables is calculated, you can just plug in that value into this equation, right? And into this equation, and then you'll get the value of a. So now we have a and b values, and so we have got a line with us, right? So now coming back to the same thing, how good fit is this line? So there's this parameter called r square, also called goodness of fit. So which is of this form? All right, again, the numerator looks very similar to this one, and the denominator is a kind of again normalizing factor. So what are these things actually called? So this thing that we saw here, it's called RSS, or residual sum of squares. So what we discussed here, let me just second. Is it working? Just give me a second. Is it not working? Okay, never mind. Okay, so now we discussed this was the axis. Let's say I'm just drawing one point here. Okay, so now we discussed that this difference for this particular point xi yi, this is going to form a part of residual sum of squares, right? Because this was the actual value, this is what value you got from fitting the line. So for this value, this is a residual, it's a difference. On the other hand, what does this value? TSS stands for total sum of squares. So now instead, if we say, let's say there was actually not supposed to be a line fitting through these points at all, right? If there was no correlation at all, right? So let's say now I draw this, right? So here we see no correlation, right? On the other hand, if this is what probably this line fit, right? So now instead, if there was no correlation, can you tell me what sort of a line would we have fitted in this?
X equals to y.
X equal to y. So that would have been a line like this, right? But that would mean it's a great correlation.
Yes.
So we were looking for a,
y equal to some constant.
sorry,
Yes,
can you say
y
that
and
again?
x equals to
Y
some
equal to
constant.
3.
Yeah. Okay. So instead, we call y as a constant here in this case, because x is like we call x as the independent variable in this case because we're predicting y, right? So we have values of x with us. Now we also have yi with us, but when we are predicting y values. So the way it's done is we are fitting a straight line like this. Okay, and now what is going to be this value that we choose? Can you think? what would be an appropriate Y value here? Think about it. These are all your points. All these points are yi's. So we are fitting a straight line. So we are fitting a straight line here, right? So what do you think this y-intercept of this line is? What could it be? It's one of
Y
these.
bar.
Value of ma'am.
Sorry, your voice is not.
Y bar.
Y bar. Yes, absolutely. That's correct. Right? Because these are all your values of y. So if you take the average, it's going to lie somewhere here. And that makes sense. Right? So now if you think about it, do you think what we did here for a straight line, so we did yi minus the this was our prediction, right? So let's call this yi bar, right? This thing in the inside bracket. And here instead, what we're doing is for each of the points, we're finding the difference from y bar and we're taking a square of that. So it's very similar to what the numerator is indicating and the denominator is for in case there was no correlation. If instead we would have just fitted a straight line without regards to, and in fact, even if it was a case like this, the worst fit line, I think that's a better way of explaining it. So again, I would like to shift your focus to the first plot here. This is what our points are. And here we are fitting a good line, what we think is the best line to be fitted. But instead, if the worst fit line is drawn, then that would be something like this, right? Wherein this is your y bar, right? So now we actually want to find how good is this blue correct line with respect to the worst fit line. And this is what our goodness of it is trying to quantify here. All right.
Yes.
All right, great. So, so this is done, and of course, higher the value. So we want R square to be high, which means this value needs to be less. So which means RSS has to be really small, TSS has to be big, because of course we expect this to have a higher value, right? Because this is supposed to be bad, and the top one here should be as little as possible. So it sort of follows, right? You can think about it. This follows. Yeah. Okay. Next up. So yeah, I don't have any. Yeah.
Now, what is RSS?
Yeah. Okay. Let me just write the.
RSS TS.
Yeah. Let me just write the full forms of these. So RSS stands for residual sum of squares. Just write this here. RSS is residual. This was not as such implicitly told in the lectures, but it's just for your overall understanding. Sum of squares, and TSS is the total sum of squares. All right. Okay. Yeah. So again, so the blue line here is for your RSS, and the red line in this case is the TSS. Okay. So interpolation and extrapolation. Now, when we are predicting anything, so it's just that you would have certain points available, right? Some value between this value and this value of x is what is known, and the corresponding values are here. Now, if you are fitting, so the thing is, you know the nature of the curve within these ranges. Now it may so happen that the curve was actually, it followed a trend like this, right? So now beyond this point, you really don't know if what you're doing is actually correct. You don't know how. So we are not just talking in terms of numbers here, but let's say this function is followed by some, let's say, so let me give you this example. I'm not explaining it in a lot of detail, but it should be enough. So there's something called as qPCR, okay, quantitative PCR. So what it uses is, so you have DNA, you're just, some part of DNA is getting, you are multiplying it many times. Okay, so every, let's say 1.5 minute, if you have n, now it becomes double of n, then it becomes double and double and double. That's how it goes. And you're measuring that thing using fluorescence. So now for a good number of time, it follows this pattern, right? It's doubling. But when it is really low, when the number of that DNA molecules are really low, that fluorescence is not enough to be detected by your detector. So it follows something like this. And then later on, it saturates. So then again, it becomes something like this. Now, since this is known, it is, so let's say you only had these values with you and you thought, okay, well, so therefore you sort of, what you assumed was that this is how it's going to behave. So now for this value of x, you predicted the actual value of y was this one, right? But what you predicted was this value. So you extrapolated because you had a certain range available with you, but you predicted outside the range and without considering what it may actually mean for your actual, set of data. Versus if it's within this range, you are pretty sure that this is how it should behave. So it should be, yeah. So this value interpolation is simpler, but extrapolation, you need to know if it's okay to do that. So in a lot of quantification applications, a minimum and a maximum is set. Maybe in the middle, some more values are taken, but a lot of times only these two values are taken, and anything less than this and anything more than this is not recommended. So you should try to have, so let's say if you actually want to quantify which has a higher concentration, you take half of it. That means you dilute it so that whatever value you get, now you can just double that and report that value. But you don't actually quantify this directly. Okay. All right. So that's the concept of interpolation and extrapolation. And so as of now, we have been talking about linear fitting. So now we saw one example, but there could be lots of examples wherein, so for a simple plot like this, okay, if I just give you data, if I just give you 100 points, 100 paired values, x and y, you should not directly, and if, let's say if I ask you, okay, find the correlation of this. So these correlation coefficients, the formula that we saw, that is actually also defined for linear data only. Okay, so without plotting and without being sure that your data is actually linear, you should not make any assumptions on it, and you should not fit a linear line through it, because, well, maybe some sort of linear line can be fitted through this, but that would not be the correct straight line, right? So you first plot the data, and R is one very simple medium to plot. So the simple function is, right, plot, and in brackets you just give it x comma y, the x variable list and the y variable list, and it's going to plot that thing for you. And so once you have that plot with you, or even on Excel, you can plot this on Excel. So once you have the shape of the plot, then depending on what you have to do, you want to fit a straight line, you want to find the correlation, or you want to predict what type of nonlinear function is going to be there, you can proceed. And two of the most commonly used nonlinear functions to fit the data are exponential and polynomial. So what I can recommend you is, so there are lots of online resources available that you can use for practice. So we can just try this for a couple of equations. So any equation that you would like to see here, you can just tell. Exponential, polynomial. So it just has to be of this form: y is equal to, let's say 3. So if this was there, then if you press this shift 6, which has this caret sign, so this goes on the superscript. Then let's say I wanted to see this. Yeah. And then I do plus 20. Okay, it goes out. Yeah, somewhere here, right? Or if I do minus 20, so it goes somewhere like this, right? So this is available. Tools like this are available. You can also check it for any exponential function. E to the power minus 1.3x, right? So these things are available. So now you can just try and see how the nature of these functions change depending on whether the power is negative, positive, and things like that. Okay, this is just for trial. Okay, any questions on this? Yeah.
And is there any 3D x square plus y square plus z square equal to 1 graph?
3D should be, I mean, 3D plots, of course, they can be made, but not with perspective of this course for now. But of course, yes, 3D plots can easily be made, and there would surely be tools available for that. Yeah.
Okay, ma'am.
Okay. And so next part of the lectures discuss probability. Okay. So simple examples, tossing a coin, rolling a dice. So whatever options are there, that whatever outcomes are possible, that becomes your sample space, often defined as capital S. And then whichever events are there that you are interested in, whichever of these outcomes you are interested in, they are called events, and they are denoted by capital E, right? So of course, S, or the number of S, is the maximum that's possible, right? So probability is about numbers, how many things can happen. So that number S is always going to, so the events of your interest can either be 0, 1, 2, 3, or they can be maximum to how many events can be possible, right? So that's just telling that. And since probability can be minimum 0, maximum 1, either something is impossible, so that becomes a probability of 0, and if it's surely going to happen, then the probability is 1. That's the lower and upper bounds. So probability of everything happening, because that is, a sample space is everything, that probability is 1. All right. So next up, there are some terms that would be good to note, right? So I'll just explain this through Venn diagrams. Okay, so typically a square or a rectangle is used to denote your sample space, and it's also sometimes called like the universe. So this is everything that's possible. And then if you're interested in two groups of events, so let's say this is one event and this is another event. So this is event A, event B, and let's say we define in terms of rolling of a dice. So in terms of rolling of a dice, S is basically 1, 2, 3, 4, 5, and 6. And let's say, so now in this case, I'm defining event A as all the even numbers. So 2, 4, and 6. And I'm defining B as numbers greater than 4. So numbers greater than 4 are only 5 and 6, right? So now you can try seeing it here itself, that the common between them is 6, and what is not common but only belongs to A. So A only, that is 2, and that's 4. And only B is 5, and what is not covered in A and B, that becomes your outside A and B sets. So now union is also called like or. So something that, so it's the option of both the things happening. Sorry, No, it's the possibility of either thing happening. So either event, or you can say, so A or B, right? So any of this happening is these four options. If when you roll a dice, if one of these four numbers come, then you can say it belongs to this union set. And intersect means only this one. Only this is happening, right? And yeah. Yeah. All right. And the complement means none of this, neither of these are happening, right? So not A or not B. So everything which is outside of this, it's often denoted as complement. So A complement. So if A is equal to 2, 4, and 6, A's complement will be anything but 2, 4, and 6. So that's 1, 3, and 5. And B complement is going to be 1, 2, 3, 4. And then just so mutually exclusive events would mean that when one happens, the other can never happen. So let's say when event A is even numbers and event B is odd numbers, then they're mutually exclusive. They can never overlap, right? And then, of course, Venn diagrams are going to help. And so this was just one of the lectures, and it will also come ahead that there are some formulas that you would see. So when you're talking about two events happening, sorry. So when you are talking about two events happening, so both happening or either of them happening. So how do you find the probabilities? Sometimes you product the probabilities, sometimes you sum them up, or can you subtract this? So for example, now let's say if I'm only interested in this one, so I would subtract the intersect from the total. So probability of A minus probability of A intersect B, that will give me the probability of only A happening. Right? Because just by default, if I'm saying probability of A, it means this whole circle. So some things like that were also discussed. And okay, so we have, I think this was really quick.
I have a question.
Yeah, sure.
Okay, so there are two things, right? Mutually exclusive events and mutually exhaustive events. Something like that is also there, right?
Yeah.
Can you please explain that?
Okay, all right. So let's say, so if I am saying, let's say, in this case, I have 1 and 3 and 2 and 4 also. And then I have, so these becomes exclusive, right? Because one does not come with the other, right? Like if one happens, the other cannot happen. And as far as I remember, exhaustive has to do with, is it mutually exhaustive or just exhaustive? Let me just, okay, I think it'll be better if I just confirm and tell you. What does exhaustive events?
Okay, is it like PA divided by B wala thing? That is probability of A occurring when B has already occurred.
Oh, no. That is Bayes theorem, Bayes.
Okay.
Or that is conditional probability and all of that.
Yeah.
No, we're not going into that. But I do remember studying exclusive and exhaustive events. When two events are exhaustive, it means that one of them must occur. Oh, okay. Okay, so let's say if you're defining it as one set of odd numbers and even numbers, right? So one of these two sets has to occur because together they make the whole sample set. And if you have an event, it's going to be in one of these categories, right? It can't be outside or outside odd or even numbers, right? Something like that. I think I need to frame it better. So I'll just note it. Mutually exclusive and exhaustive events. Okay. I'll read on it and give you a better example so that it's clear. Anything else? Anybody? Okay. All right. So we'll just try some practice questions from this week's topics, and then we'll go on to discussing week 1 and week 2's assignments, solutions. Okay. All right. So this one, what's the right answer? What does R square indicate? Are all of you asleep today?
B.
Yeah. It measures the?
I think it's B.
Yeah. Correct. Okay. So we need to calculate the sample covariance of the data set. So I have these entered in an Excel file. So can you tell me what all calculations should we do? Yeah. So first of all, how should we proceed with it? What are the steps? You want to find the covariance of the data set. Right? Remember the formula? This one.
First, we have to find the mean.
Yeah. All right. So of course you can do this using paper and pen, but it's always good to also know how it's done on Excel. This will come in handy, if not from the perspective of the exam, but otherwise in general, it's good to know Excel. So we'll find the mean. So mean and then bracket, and then we just select these numbers and then bracket close and then enter. Oh, so mean is not the function. I think it's average. Average of these numbers. Yeah. Right. Likewise, we do this one. Find the average. Okay. What next?
X minus X1.
Yeah. So we'll write X minus, let's just call it mean for now. And we'll also do the same for Y. So here we'll do is equal to this value minus, instead of selecting this, it's better to write this down because otherwise it'll just shift. As we shift this one, this is also going to get shifted. So we'll just write 4 in this case is equal to, and then we'll drag this whole way. Likewise, we'll do this minus 8 and we'll drag this. Okay, what next?
Sigma X minus.
Sorry, say that again.
Multiply the both.
Multiply
and
them,
divide by
right? So the product x1. So this is equal to this multiplied by this number, and that's it. And then what do we do with it? We first sum this up. I mean, yes, you can divide it first and then sum it up, but just simpler to sum this up first. And then you divide it by how much? We have 5 values
4.
here, right? So 80 divided by, and that you get 20, right? So the covariance, right? So the covariance is 20. All right. Would you also like to go one step ahead and calculate the correlation coefficient? It won't take much longer, right? So can you think what should the correlation coefficient actually be? Can you give an estimate?
Covariance of X by.
Sorry, you will have to be slightly louder. Hello?
Covariance of XY by standard deviation of X into standard deviation of Y.
Yeah. All right. So how do we calculate the standard deviations? What other parameters do we need to calculate?
Sigma variance we have to calculate.
Yeah, so after this, what calculation should we do? What another column can I add to the table?
Square.
Square
X
of
minus
this
X
number.
per 2 square.
Yeah, so let's just write it as x minus mean. Just writing the column names here. Likewise, we can
Y minus Y bar square.
have this. Yeah, okay. So this one is going to be y minus mean and square of that. So this is going to be this value multiplied by this value. And likewise, this multiplied by this again. Next up, we also find the sum of these,
Sum.
right? So, sorry. Yeah, find the sum. And also find the sum of this one. What next?
Product.
Not the product. We want to find the standard deviation of x and we want to find the standard deviation of y. This is not the standard deviation yet.
Sigma x minus x bar square by n.
By n minus 1.
N minus.
Yeah, so we'll divide this 40 by 4 and we'll divide this as 160 by 4. Then
Square root.
square root. That's a very important step, right? So we want to find the square root of this number and we want to find the square root of this number, and then we can multiply this and divide 20 with that. So we can just have 20. Yeah, so here it's going to be 20 and then we're dividing it. Yeah, this multiplied by this, and that's 1. Yeah, and that's what we expect also, right? Because if you plot this, so you have x as 2, 4, 6, 8, and let's say here I'm taking this width as a difference of 2. Now just to plot it, you remember in school this is how in graph papers you're supposed to plot, right? 1 square, you can keep it as different scales. So here I'm taking it as 4 units, here I'm taking this as 2 units. So if I just plot this like that, you would see it's a straight line fitting right through the origin, right? So the sample covariance is 20 and the correlation coefficient, because we are fitting a straight line and it's a perfect fit, that gives us 1. Okay, next question. So a bivariate data set, bivariate simply means 2 variables, okay, is represented on this graph. So what do you think is a likely correlation coefficient for this out of these values?
Minus 9.
Option D minus.
D.
Option D. Yeah, okay. And for this data set, what is an approximate value? So we can go
1.
again. Yeah, good. So again, like I've said, we could go and calculate the actual value of correlation coefficient, but we are asked an approximate value. So you can just try plotting it. So the first point, so it's 1, 2, 3, and 5, and 7 on the x-axis, and it's 1 and 5 and let's say 8, 12, and 15. So it's roughly fitting a straight line. So it's a very high correlation. I mean, it is fitting a straight line, and this straight line is, so it's an equal, so single increase in the x-axis like a double increase on the y-axis. So the approximate correlation coefficient is 1. Okay, so if S is the list of all possible events, what is the probability
1.
of S happening?
1.
Right, because
Number 1.
something, yeah, because something has to happen in that, right? So something will definitely happen. Okay. So if S is this whole list, 1, 2, 3, and few numbers missing here, E3, yeah, it's just called E3, E4. How many elements are there in S minus E3 minus S4? Right? So you can just remove this like this. So 1 is there, 2 is there, 3 is there, 6, 11, 1 and then 3 and then 5
Six.
and then
Five.
6,
6.
7. Yeah, 1, 2, 3, 4,
D.
5.
D.
So B, right? Right, 5 events, 5 elements are remaining. Yeah, okay. Okay. For the role of an unbiased dice, so unbiased means the probability of each of the part events happening, each of the numbers is equal, right? So it's 6 events, so 1 by 6. If it was a biased dice, maybe 2 of the numbers had a higher probability of happening, and or something like that. So an unbiased dice is rolled twice. What is the probability of 5 showing up 2 times? Okay, so this
1 by 36, ma'am.
yeah. So thing is, now you have, so let's think about, so basically what you want is 5,5 occurring, right? So you want 5 and 5 to occur, right? So whenever you are doing, so whenever there's an and, you're always multiplying probabilities. So what was the probability of 5 occurring? There were 6 probabilities, one of the events, so it's 1 by 6. The other one also 1 by 6, and then you multiply them. If in this case it would have been 5 showing up at least once, okay, or something like that. So we won't discuss that right now in detail, but when you're talking about 2 events, one of the 2 events happening, then it's an addition, right? But then in addition, you need to take care. So here in this case, what we're doing is these are 2 mutually exclusive events, and uh, rather than so basically what exclusive also means that one is not going to affect the other. The fact that 5 occurred the first time,
Independent events.
sorry,
Independent events. Probability of A intersection B equal to probability of A into probability of B.
yes, probability of A into B, exactly. So but that we are able to say because the first event happening is not affecting the second event happening, right? So
Yes, ma'am.
right,
Independent.
right, they're independent also. So that's there. So right, in this case it's 1 by 36, and so just the same thing, just to make it clear, if it's rolled thrice, it's going to be
1 by
just
2, 1.
1 by 256.
No, 216. A
216.
will be there.
216.
Yeah,
Sorry.
36 into 6. Yeah, 216. All right. So, and like I had mentioned previously, in your exam, you will have access to an online calculator. So, always do these products there so that you don't make a mistake in mathematical calculations. Okay.
Will that be scientific calculator?
Yes, it'll be a scientific calculator.
Fine.
Yeah, okay. And I think that's the final question from this set. So, what is the probability of only event B happening? So, which is?
Ma'am, C.
C.
Yeah, all right. So, this one. All right, good. So, we have time so we can actually discuss all the questions from week 1 and 2. So, I think, yeah, I just have these PDFs open. All right. Yeah, I hope you can see the screens. See the screen. Yeah, the questions are visible. Okay. So this was a question, right? So 2 examples are given: the temperature change and root and shoot length as an indicator of plant growth. So when we're talking about change, it's going to be like an interval, right? And while it may not be completely clear, but in this case as an indicator, so it means we are talking about a ratio in this. So yeah, so we're just talking in terms of a relative scale.
One question.
Yeah.
Why option A can't be the answer?
Why option A can't be an answer? Okay, so see, discrete only means that it will not have anything in decimals. It's only going to be whole numbers or natural numbers or integers. But when you're talking about length, it can be 3.15289, whatever, right? So none of these are discrete values. So option A and C are anyways cancelled. Right?
Okay.
Yeah.
But in the weak one concepts, this internal and the ratio variables, they're not covered.
Yeah, I understand
So
that.
without covering, if you frame the question, how can we know that?
Yeah. So I can convey this to the instructor.
He's covered in the concept in the videos. So definitely we'll answer that. We'll try to answer.
I understand.
But but in the
Yeah.
videos and even in your problem solving sessions also,
Yes.
you discussed about only continuous and discrete variables only.
Yeah.
And
Right.
these concepts, interval and ratio variables concepts, not at all
Okay.
discussed in the videos and in your sessions also.
Okay, fine.
Even
So,
ma'am, one question come in this third week assignment, which lecture is in the fourth week. That probability part, from the probability part.
okay. Can you
Rolling
tell
a
me
dice.
which question it is? So, yeah.
Wait, man, for that. Okay, you just continue. I'm saying
Okay.
that.
All right. Okay. Because I understand that there are a couple of questions in week 2 also. So, I will convey that these questions are out of the discussed topics. So, how should the grading be done? All right. So you just point out the questions. I'll note those down and tell him. But for the timing, since we can't directly do anything about it at the moment, so we'll just discuss the solution. So at least that's clear from the point of view of learning. Okay. But of
So
course,
that's why if it is not covered in the sessions, and if you lose that marks, it definitely it will
of
affect
course,
the
of course,
assignment
of
marks.
course, I will convey this. So,
Thank
which
you.
is, of course, yeah, don't worry. Okay.
One
So,
more thing, the discussions are happening twice, right?
yeah.
So the other person who is taking the interactive session is not well versed with the topics. Sometimes I feel.
Okay.
So can you convey this thing? Because
Okay.
I have when we have to fill the feedback form, I have written that it's not up to the mark. So I don't know whether I have they won't be knowing to who to which instructor I'm like referring
Oh,
them.
okay.
So
No worries.
apologies for that.
No problem. Okay, I'll try to convey that too. Okay, sure. Yeah. Okay. All right. So, so this is telling you the doubling time in minutes of different strains of bacteria. And yeah, you just need to find the time which has the highest frequency, which also means you need to find the mode of this data. So simple, you just calculate and you'll see that 20 has the highest frequency here. Okay.
No, I have a doubt, ma'am.
Mm-hmm.
Is there any shortcut to find the geometric mean, ma'am?
Is there
Manually.
any shortcut to
Find geometric mean manually
No,
without.
it's only you need to find the product and then you find the nth root. There's just formula based.
Yeah, in the exam, how to calculate? No, you have by using online calculator.
Yeah. So you will have the online scientific calculator available to you in the exam also. All right.
Okay.
So yeah, absolutely. You just multiply all the numbers that you have and just be careful that. So just practice on that. When you have the number, you use this caret sign as the power, and then you use the right notation to find the nth root. Either it's going to be 1 by whatever n value, or it's going to be in decimals if you already want to calculate. Let's say if it's n is 4, so you either write 1/4 or you write 0.25 in the power. So just you need to be careful about that. And yeah, that's
Okay.
the only way to calculate geometric mean.
Thank you.
Okay. All right.
Which question I was asking for that out of this week
Yeah.
sections, that is 9th question.
Okay. All right. Fine. I'll mention. Okay. So then third question here is, so what is the average performance? So again, this is arithmetic mean. So this we also touched upon in the first week that so one of you had asked that if arithmetic mean is not the best sort of notation, or it's not the best mean, why is geometric mean not used in all of these places? So it's just a choice of, it's a matter of preference. So likewise, if here nothing's mentioned, but in this case it's saying average, so average is synonymous to arithmetic mean. So again, simple formula, you know how to calculate the mean, so that's there. And so yeah, so we don't need to discuss this, right? Municipal corporation sent 5 samples from its water supply for microbial testing to test the number of bacteria in some unit, and it showed the following values. So what would be a statistically reliable average? Right now, when this is said, so here it said statistically reliable average. So here you need to be careful that instead of, because you can see that the range is huge, right? You have values from 5 to 500. So an average, the arithmetic mean would not be a reliable average. So instead you calculate the geometric mean, right? So you find the geometric mean and yeah, you select that.
Instead of geometric mean, why don't we calculate median, ma'am?
Yes, ma'am. That is the thing that I give there the 100 option. It is similar. There is two number 100 and 111, which is too closer. Na? For that, if we can arrange it in ascending or descending order, and if we could measure the median.
But the median would be
and madam, even
15, right?
Even that for 25 reliable average also, for 500 is outlier. Then why it is a suitable reliable average for that data set?
Say that again.
Yeah.
You are telling statistically reliable average means we need to find geometric mean.
Yeah.
So if the geometric mean is 25 for the data set, then even that 25 also not reflecting that 500 value. It is the 500, if we consider this data set, that 500 is outlier for this data set. Then how it can be a reliable average for the given data set?
Exactly.
Okay.
So if you arrange in that, then 5, 10, 15, 25, then we'll get the 500.
Then we will.
So if the reliable average is 25, so from the mean value 25, that 500 is so far it is a too much outlier.
Yeah. So
Then,
we are not saying that 500 is not an outlier. It is an outlier.
Of course, if it is outlier, then how that average 25 reflecting that 500 also in that?
Yeah. So the purpose, so what an outlier means is that we do not want it to affect any of our calculations. If you would have taken the average, if you would have taken the arithmetic mean, so I think, so 500 plus, this is how much, 20, 30, 55. Right? So yeah, so it would have been 111, right? So outlier means that it is an extra observation, might have been because of some error, but it is an observation right now. As of now, we cannot just remove it. It's there, but whatever preliminary calculations we are doing, we do not want it to affect that so much. So if we would have calculated the arithmetic mean, which would have been 111, it means that this 500 has actually affected it a lot, because these 4 values, the other 4 values, they are lying on one side of the number line, 500 is on the extreme end, and this number is very different from, so this number is very different from what would have been there if 500 was absent, right? Because if 500 was absent, then the mean would have been something around 16 or 17, I think, or I think 12, whatever it is, it's something around 15, right? But now when we have taken the geometric mean, when 500 is present, the geometric mean is 25. When 500 is absent, then also the geometric mean would be something around 15. So the difference is not much in geometric mean, whether or not you have the outlier or not. So outlier is a data point. You have not removed it yet, but you also don't want it to affect your calculations.
Okay, now if it is in case of the given data set, if 500 is not there, for example, it is 100 is there. So
Then
in that
also
condition, for the statement statistically reliable average, so even we can go with the arithmetic mean also.
Yeah,
because
so
it's normal average also.
True. So again,
So
like you said,
as per your first week problem solving session, so given one question and you asked that, so which is suitable for that, either geometric mean or arithmetic mean?
Yeah.
In that question, that outlier was not there. So in that one question you mentioned, so for this question, this arithmetic mean and even geometric both are not suitable to mention that average. You said that statement.
Yes.
So then in case of this one, the 500 is a more far outlier. And so then what is the need of using this reliable average term?
Okay.
So anyhow, in a given data set, so based on the values difference only, if any outlier is there, based on that only we will consider either it may be normal average, that means arithmetic mean, or we'll go with a geometric mean. So in case of this situation, if it is reliable average, means that average should reflect all the values in the data set. So
No,
but in case of geometric mean that
no. Reliable average does not mean it should reflect the data set. So outlier, the definition of outlier is, it's a point, it's an observation, but it's very different from the other points. So we still don't know if it's actually relevant for the data set or if it's just a spurious observation. So reliable average does not mean it needs to reflect the outlier also. Reliable average means it needs to reliably reflect the non-outlier data points, more importantly, than get affected by that outlier.
So here always in that the statement is mentioned statistically reliable average for any given data set. So definitely we need to go with the geometric mean calculation.
So you need to go to geometric. So it's like, so they are both averages. So let's say if there was not an outlier, then in case if you are posed a question that find the average.
It is not about outlier, madam. So for here we are clearly visible that the outlier is visible. But in case of a large data set, here only 5 points are there. So even we can, by seeing that, we can tell that outlier 500 is outlier. We can tell that. But in case of a large data set, sometimes we are unable to find that which one is outlier.
True.
So unless calculating that z score.
Yes, true.
Let's calculate that.
So
in a given data set, how can we know that whether it is that geometric mean is reliable or arithmetic mean is reliable?
Okay. Yeah. So good question. I don't know if there is any test or any metric that will tell you how reliable it is.
From the examination point of view also, if we get the term reliable average means, so definitely we need to go with the geometric mean calculation.
Most likely, yes, because again, most likely because there would be an outlier in it. That's why such a term would be used. Because like I said, by default, average is used for arithmetic mean, right? That's what you say mean in general.
Right? In case of mathematical terminology, definitely we need to consider geometric mean only.
Should be, because these are the only two averages, because median is not normally called like an average. There are only two averages synonymous with mean. It's either arithmetic mean or geometric mean.
Of course, madam, but if in the question it is mentioned reliable average means, definitely we have to use geometric mean only.
And like I said, this term will only be used if there's an outlier, and which is why arithmetic mean is not a good notation. If the outlier was not present, then both of them are equally statistically reliable. Then it's like you have two options correct, so that won't be asked from a questions point of view.
Ma'am, one question. Where do we use harmonic mean?
Oh, harmonic mean is also there. What that's like the inverse thing, right? 1 by harmonic mean is equal to 1 by A plus 1 by B, like that. But since it's not discussed in this course, like everybody else don't get confused by that. But yeah, harmonic mean is also one average, but I am not sure if I can relate it to when it's the most appropriate to use. I'll have to check.
Okay.
Yeah.
Ma'am, how can we find the roots for the other than the square roots for this geometric mean?
Okay. Let me show you in the, see if there's an online. I'll just open one.
We have to take the log, no?
No, you don't need to do that. No. So let's say I'm just finding out. So let's say I want to find this geometric mean, right? This, where did it go? These values. All right, 5, 10, 15, 25, 500. So what I'll do is 5 multiplied by 10 multiplied by 15 multiplied by 25 multiplied by 500. Right? So this is giving me this value. Now what I'll do is, let me just type this in again. 9375000, and then you see this root thing here. So there are two ways.
Yes, ma'am.
Right? So if this root is available, okay, in that case, root is written before this. I'll show you both the options. So I'll first type this, and you see the cursor is here. So I need to find 1 by 5. So I can write it as 0.2 also, right? So when you want to find the root of anything, that's 1 by that number. So when we find the square root, it's 1 by 2. When we find the cube root, it's 1 by 3. Now in this case, we have 5 numbers. You want to find the fifth root. So it's 1 by 5 or 0.2. So I'm writing 0.2, and then I'm writing this number here. It's 9. I'm writing it from the keyboard. 9375.
Here we take n only.
So if this n is not there, yeah, I'll just tell you. So this is your, what happened here?
Now we should take n only. We have to take 5, not 0.2.
Oh, good point.
Because
Okay.
you are
Yeah,
taking the root. So you have to
Okay.
take 5.
Sorry. Yes. Thank you. Right. So this is n. So this is one way. So we got roughly 25 here. And there's one more way you can do this. So if I'm right, 9375000, and you see this a to the power b option. So if I do this, the cursor automatically goes here. Now here I will write 0.2. Okay, so here you get the same values. So the fifth root and 0.2. Anything.
Excuse me, ma'am.
Yes.
Yeah, for the same question, just now I checked in the Google. So what is the most reliable average means they are telling about median only. The median is the most reliable. So they mentioned about in the Google. The most reliable average depends on the context and the type of data you are working with. And the median is the most reliable because even if there were outliers, it would drastically change. So therefore, it is the most accurate measure to use.
Okay. Yes, you have a point. So, okay, I can also discuss this with the instructor. But I can just tell you that if you find the mean of this, if you find the median of this data, that's going to be 15. 15 is not one of the options.
Of course, madam, here we are having a lot of time to solve this. But in the examination point of view, so once we take that values and if we calculate the arithmetic mean also, so definitely we'll see that answer.
Yeah.
So if the after calculation, if we get that answer, definitely we'll choose that.
Okay. Yeah.
So if the answer is not there, if we calculate the arithmetic mean, if the answer is not there, then we'll go with the second
Yeah.
thinking.
Yeah.
But after calculation of normal, what in case of average means, we'll take the arithmetic mean only. If the answer is there, definitely we can't go with the geometric mean or what you told harmonic mean or other means. We generally we won't go.
Yeah. Yeah.
So here the term reliable means. So I want to know.
Okay.
Exactly.
Okay. Fine. I will. Yeah. I'll get this clarified. Thanks for pointing it out.
And
On this-
one more thing,
on this very
one more
topic-
thing, this introduction to biostatistics, not only mathematicians, even the people who are from the non-mathematic background also, they'll do the research works also. In that condition, definitely they need to calculate the average or what you call that reliable average. In that condition, which thing they have to use, since arithmetic mean or geometric mean, other means or the mean, mode or whatever it is. So they should have certain exact point to for the understanding. So for that purpose, I'm asking. So it is not about that one point for the exam assignment purpose.
Yeah.
So
Yes.
since we are discussing geometric mean only, we can go to question 8. I mean, it's also based on geometric mean. Over
We'll-
there, I
we'll-
feel like we
We'll just
cannot
come to
answer
all the
because-
questions one by one. All right, it's not farther away. We are already on the 4th question. We'll come to it. I think, right? Let's not skip questions. So, again, I would like to say that there are these rules. Of course, it's there. But again, finally, what is used in the actual case scenarios is very highly dependent on the field that's there and how it's done in that field. So this course is only from the point of view of explaining that these are all the things available, these are set rules, but then how you use it once you start working, it's really on how you are taught in that field, because once you start, what are the norms that you will understand once you join, right? So I mean, we can either cover the rules here or we can go into details of why is geometric mean not used so often, in these studies that you see. But again, I think that's very specific to each field. It's a good thing to note, and it's good to remember if, whenever you start. But I don't know how much we can rationalize that. Okay. Any other questions before we move on to question number 5? Okay. All right. So this one, so 100 cells, they have been divided into groups of 20. How many cells have with these speeds each? So what percentage of cells are within 60 micrometers per second? So you just need to add this up. So 25 and 35 is 60, and then 78. So 78 out of 100, which is 78%, right? So yeah, a lot of ways to do it, but simple calculations. Question 6, the cell membrane proteins, the cell migration speed. So the median speed. So median, just be careful of arranging this in descending or ascending order, and then taking the middle value or the average of 2 middle values. So in this case, we have 8 numbers. So once we arrange, we take the average of the 4th and the 5th number, right? So it's 0.25. And given below the number of viable bacteria obtained from various, so viable bacteria, you need to find the mean absolute deviation. So that's the formula, right? So here you take the difference, and instead of you squaring it up and finding the root of it, here you just take the absolute values. So simple calculations. Just be careful with making all of these as positive values, sum it up, and then you divide it by n. So we discussed that while it may be good to also divide this by n minus 1, such a formula is not present. So in case of mean absolute deviation, you just divide it by n, right? Versus in case of standard deviation, there's this correction available, so you divide it by n minus 1. Okay. So here it says it's, one decimal place you need to approximate. So the value came on to 1.17, and when you take estimated, it's 1.2. Okay, so yeah, so question 8 in this case. Yeah. So this one again, so 7 weeks, and what do you expect in the 8th week? So you could have done it in 2 ways. Either you plot it and you see where the trend is going, but the other way, which probably is slightly more accurate, is that you go for the average. But now again, you can think that why is geometric mean taken in this case? Why not the arithmetic mean? So this is another question I can ask. Yeah, but you just, for now, I just want to explain why was such a thing done. It's just so that you have an average with you. So that's what averages also help. So it means that whenever you do it a random time, this is what you this can be one number that you can expect. But of course, why geometric mean? Why not arithmetic mean?
Is geometric mean is more representable than the average?
It is said to be more representable in case of outliers. When there is not an outlier, I don't think it's not said that one option is better than the other.
Then here there is no outlier such.
Not as such. Yeah, you can say 25 is slightly outlier, but I don't think it makes sense.
Yeah.
Whereas it is in ratio, in percentage. So if that main number is lesser, that 25% of 5 is much lesser than the 15% of 100. Like that, if we think it in such a way, then this is the ratio. Then there is no meaning of getting the geometric mean of these. There is no outlier such.
Yeah, there is no outlier as such. True. So which is why was geometric mean
Calculated,
considered? Yeah. All right. So
Actually, in the lecture, this was not explained that to calculate the rate of degrowth or something, you need to also use. It was only mentioned that in cases of calculating means where there is outlier, you use geometric. This is something totally different. In fact, I feel like this question only shouldn't have been asked because it's an experiment. How can you know how the
yeah. So
thing
the
is going to
question
be in-
here is, so the thing is that the geometric mean is not calculated specifically because it was like a percentage loss sort of a data. Had it been these numbers for any other data, not percentages, let's say if it was, I don't know, something else, some length, still why geometric mean is calculated in this case, that's what the argument is, right? So either we would like to know why a geometric mean is calculated as opposed to an arithmetic mean, and either we should know that, or we should know if it's specific to this case, such a thing was not explained in the lectures, right? This is what we want to get clarified.
Based on the questionnaire here, like arithmetic mean finds to be the most perfect, I mean, the calculation to be like, as you mentioned, since there is no outlier, so why not arithmetic mean? I mean,
So the thing is, when there's no outlier, there is no choice as such. I mean both are equal good choices.
because if you calculate arithmetic mean, the answer will be 12. But if you calculate geometric mean, the answer is 10.
Okay, fine.
So in that case, it makes incorrect, right? And we have missing point here.
Yeah, of course.
Sure. The assignment, all the wrong answers were also options. So
okay. All right, fine. Yeah. All right, I'll ask this. Okay. Anything else? Yeah.
No, I'm good.
Okay. All right, question 9. So calculate the mean and standard deviation and just write it in this form. So mean, simple to calculate. Standard deviation, also simple formula. We just simply plug it in and we get this value. And the last question, I think, from this assignment. So yeah. Yes.
Before you move into question number 10, like as you mentioned, like during the examinations when we'll be giving, I mean, in-person exams, so we'll use the online calculator, right?
Yes.
So, and I just saw you using the Desmos ones, this one, yeah. So how do you are gonna calculate a standard deviation? I mean, you have to go to all those lengthy process, right?
Yeah.
Yeah.
So the thing is, you will also
It was
have
very straightforward
paper
in the
with you,
Excel.
right? You'll also have paper pen with you. So, not like not as easy as doing it in Excel or R, but this is what the course demands. So you have a
Okay,
little
so
bit
we'll
of
not to carry any scientific calculator with us. It will be
no.
just the online.
No. So, as far as I know, you will be given a set of instructions before the exam. So personal calculators will not be allowed, but you will have access to an online scientific calculator. Yeah.
Sure. Thank you.
Yeah. Let me just confirm this once, but 99% you will have access to it. This is what I know from the other courses. But it's
One
worth
more question I had
confirming. Yeah.
before you move on from this assignment. So you calculate the relative frequency and then you calculate the cumulative relative frequency. So can you, when you say I'm normalizing something, is this called normalization when you're taking out relative frequency? So in what should I say? In comparison to all the other values of the data set, this is the relative frequency. So is this called normalization of data?
So normalization, so let's say, so when you're talking about just one data set, normalization will not mean much. But let's say I did this experiment twice. All right. So here what I'm doing is I'm tracking the speed of 100 cells. So now I know that the minimum speed a cell can have is 0 and a maximum speed a cell can have is 100. So these are the numbers in the second column. This is what frequencies I got for each of them. So now think of this, if I just know this much, or rather if I just know what the question is asking. Right, now let's say I did the experiment again and I got, instead of 35, I got here 15, or let's say I got 17 cells, right? And I'm just not, I actually did not keep in mind the other things. I have cells in each of the other groups, but I'm just focusing on this one right now. So what I got was, instead of 35, now I get 17. So I'm like, oh, now only, let's say I made some changes to the experimental setup. I changed something to the cells. I grew them longer. I grew them at a different temperature, whatever I did. So I'm saying, oh, instead of 35, I got 17 cells, which is like half. So I can say, oh, the lower speeds are less, if that's what I'm concluding. But actually what happened was I actually had just half the number of cells. Instead of 100 cells, I had just 50 cells. So this is why percentages, so initially what I got was 35 by 100. So 35% of the cells were in this ratio, or in this fraction. Now I have 17 out of 50, which is also roughly 35%. Right? So when I normalize my two data sets, then I'm able to compare data sets, because the sort of the total is normalized. Otherwise, I was comparing 100 cells and 50 cells. Now I'm comparing 100 cells and all, because when I'm taking percentages.
And how
So
are you normalizing it? By dividing it by the sum of
total.
the frequency?
Yes, dividing it by the total. That's the simplest form of normalization. So basically, finding percentages is a form of normalization. Or when you, instead of percentages, often you see numbers being reported between 0 and 1, right? So 35% can also be said as 0.35. So that's also normalization. So basically you are setting the minimum and maximum, right? 0% and 100%, or 0 and 1. So it's no
Basically,
longer
data of one set more comparable to another,
Yes,
even though
exactly.
there are some changes between them.
Absolutely. That's the purpose of normalization. You want to compare data sets. When you just have one data set, finding percentages is what you're doing for the question here, but you don't know what it's helping you in, right? But now you want to compare. Yeah.
Okay.
So that's the purpose of normalization, to compare two or more data sets. And so this has
Excuse me,
30 individual cells. This is
Excuse
how
me,
much?
before going to that
Yeah.
question,
Yeah,
the
yeah.
previous question, can you,
This one or the one that we were discussing?
the percentages.
Yeah.
Projected, no, after the maybe sixth or seventh question, the sixth or seventh. 5%, 10%, 25%, that question.
Oh, okay, okay. Wait. Where is it? This one?
Yeah. No, no. Seventh or
Mm.
Ma'am, 8th question.
Okay, yeah,
Yeah.
yeah, yeah.
So you calculate this question because it is considered the weak one. So maybe geometry mean or arithmetic mean used and solve this one. So can we solve this question based on the interpolation and extrapolation after third week?
Yeah, yeah, exactly. So that because in
If
that
this
case it
same
would have
question
been,
comes up, if the same question comes in third week assignment,
yes, yes.
can we, is there any possibility, can we solve this question based on the interpolation or extrapolation?
So the thing is, if we would have, so if I can draw this here, so let's say I had,
almost Gaussian shape curve we will get.
yeah, right. So
except
this
one
was
point,
from 1 and 7 roughly. So in that case, if we are, so this was 7. So in that case, if this was week 8, then we would have predicted a very lower value. So in that case, 5, right? 5 would have been like a good option, right? So arithmetic mean gives us 12, geometric mean gives us 10, extrapolation gives us 5. So definitely we need some clarification
Yes,
on this
ma'am. From
question.
exam point of view,
Yeah.
it will confuse us a lot.
Absolutely, absolutely. Sure. Okay. Yeah. Okay. So organize this data into 5 intervals, and you need to find the difference in the percentage of cells in the third and fifth interval. So you find the minimum and the maximum values here. So this one's minimum is 102. Yeah, this one, and the maximum is 172, which is here. So you have a total range of 70, and you want to divide it into 5 classes, 5 groups. So the interval, the length of each group is going to be 14, right? So 102 to 16, 117 to 131, and so on. And then you can just calculate. So now when you're finding these ranges, just be careful that in this case, this is going to be the starting value, the ending value, you add 14, and then the next group starts 1 later. So because in this case, you have, so these are discrete values, right? So when we are ending one group on 116 and we're starting the other group on 117, we are not going to miss out on any values between these two because there aren't any. Otherwise, what is done is you take 102, you end it at 106, and the next group starts greater than 116. So 102, so greater than 102 to 116, greater than 116 until 131, then greater than 131, and so on. But here there are discrete values. So you can just
6.1 will fall in the second class.
Yeah. Anything. So even 116.0001, that should also fall into some group, right? So which is why instead of 117, you would have taken greater than 116.
Just one point here is that if they give us very large data sets, then a lot of time is going to go in filling these typing, and it'll be difficult to finish the paper because there's no shortcut to doing this, right? We'll have to type all these numbers down.
Yeah, so the questions would be given you such that they should be, completed in the given amount of time. That would be taken care of. I don't think you need to worry about that. Yeah. Because I understand this, a lot of questions in this course that you have seen until now and you will see ahead, they are a lot about actually calculating, and you've seen how the instructor is also solving those on paper, right? So that has to be done. There's no shortcut to it. But of course, in time and how much needs to be done, that would be taken care of for the exam. Okay, so yeah, you have these intervals, you find this number, so you just have, so you have 10 out of 30 and you have 3 out of 30, right? So these two values, and you want to find the difference, so you subtracting, right? So 0.334 minus 1, so 0.234, and 0.234 in percentage is 23.4. So the closest number was 23 in this case.
Can you give the rationale behind adding the second class relative frequency, cumulative frequency to the first class to arrive at that value?
Okay, okay.
Is it that 40% between 117 to 131? 40% of the values are
Yes.
in
Yeah.
that range?
Yeah. So this last column is only to tell you that once you add all the relative frequencies, if you're adding 0.2, 0.2, 0.334, 0.166, 0.1, you'll ultimately get 1. It's just to show you all of that. The final column is not required for this question. So what you only require for this question is this. You're defining the ranges, you're finding the frequency, and you just want to find these two. But it's just like a sanity check. So in case, let's say you just by chance you wrote it as 11. Okay. So if that would have happened, if it was 6, 6, 11, 5, 3, if you're finding the relative frequencies, you would see it's not coming up to 1. So you would know something is wrong. So you won't make the mistake. It's just, to have like whatever you're doing is correct. Otherwise, this last column is not required. For that matter, you only need these two numbers, right? Yeah.
Okay.
All right. Okay. So we have done week 1. So here in this case, we are going to ask about question number 8. This one, also geometric mean, question 4. And then the first one about interval and ratio variables. Yeah. Okay. Now coming on to question number, assignment number 2. Here also we have a few things to discuss. Okay, so simple thing, what is the range of the given data set? Right, so 15 minus 2.5, this is already arranged in ascending order, so 12.5. What is the relationship between standard error of mean and the population size? So this one's based on the formula, right? So SEM and population size. So when n is going to increase, since it's in the denominator, SEM going to decrease. So it's an opposite trend. So only option A fits.
Can I ask something, like if
Yeah.
by the formula, if you see the standard error of mean is like standard deviation by your sample size, right?
Yeah.
So since we mentioned here the population size, so is it
okay.
dependent?
Okay. Yeah, good point. Very good point. Yeah, worth inquiring.
Though my answer is correct, but
Yeah, no, it's a very valid question. Because while we are focusing on sample and population being two different things.
Because whenever we calculate standard error of mean or proportion, we always include sample size, never population size by formula.
Right. So good question. Thanks for pointing it out. Okay. All right. So some RNA polymerase has been purified. The time taken for the enzyme to complete one set, all of these. So basically elongation time, some time observation in whichever units are given. You need to find the standard deviation and the standard error of mean. Yeah, now in this case, yes.
Yeah, sorry. I like during this, I mean, particularly the week second assignment. So it was a bit of confusion, like whether to calculate the standard deviation in terms of population or in terms of sample, because I mean, I'm not very much, I'm not able to recall which questionnaire it was. So we had to calculate the standard deviation. So even in the like question, it is mentioned sample, but when the answer I cross-checked, it wasn't the option, and then I had to do the population one, and it was the similar.
Like in this one, there are 10 observations, and then you need here it's dividing it by 10 rather than 9. Right?
Yeah, exactly. I mean, there are lot many questionnaires like this.
Okay.
It's very, because I got confused when to calculate the standard deviation in terms of population, in terms of sample, irrespective. It is mentioned sample very clear in the question, one of the question. Maybe you'll come across. And then I was looking for the option for the answer, so I couldn't find the similar one. So then I was like, okay, what's wrong? I have not done any calculation mistake. I cross-checked and I thought like, okay, give a try for the population one, and the answer was the population one.
Okay, all right. Fine.
So
yeah, this is
how
what
to do these things during the examinations time.
Sure.
Because we won't be having that much of time to our patients to cross-check each and every method.
Yeah. Sure. I have noted this down. So both question 2 and 3, again, to be divided by n, or what, like the population versus sample confusion. Okay. So yeah, question 4.
Yeah, likewise this one. You can see the sample is mentioned here, but if you calculate in terms of standard deviation for sample, the answer will be similar.
Yeah. All right.
Because it's divided by 10. And it's clearly mentioned, like, I mean, there, if each sample undergoes 50%.
All right. Okay. Sure.
And I was very fortunate that there were no two similar answers, then it would have definitely been wrong.
Yeah. All right.
Because it would be really difficult, like either to look for, what the instructor is looking for, either the standard deviation population or the sample. But technically and ethically, this is the sample one.
Yes. I understand. All right. Noted. Okay. Okay. Now, so cell count is given for 2 different conditions. Now here it's asking to find the coefficient of variance. Was this discussed in the lectures, this term coefficient of variance?
Yes,
you had coefficient of variance, like dividing it.
I saw the videos in which we have the prior recorded lecture.
No, it was not part of the
It
lecture.
was not discussed.
Yeah, I think only variance was there, not coefficient of variance, I guess.
Coefficient of variance wasn't discussed.
Yeah, so because variance, standard deviation, that's there, and coefficient of variance, the formula is standard deviation by mean. So while you can Google it, but again, this was not discussed. So I'll ask this also. All right. But yeah, so just to explain how such a question is solved. So we know how to calculate until standard deviation, right? We find the mean, all of this that we have been doing it on Excel. And then, so coefficient of variance, like a normalization thing, but yeah, so it's standard deviation by mean. So you do this for both the data sets, for the 10% and the 15% data sets, and you report that. So it's 0.09 and 0.44. So this one. But again, we'll ask. Yeah. This one also, so what you're given is you're given the first 4 moments about 0, which are these 4. And what would be the third moment about the mean? So we did discuss a few examples, but entirely
formula was also
not discussed. Yes, I understand. Yeah. So
okay,
question.
All means of 0.
Sorry.
All moments about mean when it is 1, 3, 5, 7.
Yeah.
It is
So
0.
that is applicable for symmetric distributions. Right. So, but now just from 4 points, you cannot predict if, these 4 points are not data points, actually. These are your 4 moments. So that 1, 3, 5 thing, that the moments about mean is 0 for symmetric distributions only, because it's you will have equal number of values in equal distribution on the left of mean and the right of mean. So they, when you take a difference, they cancel each other out. So that becomes 0. But so luckily, if you've done that concept here, it's fitting. But here it does not say that our distribution is symmetric. Right? So
Distribution should have been mentioned, ma'am.
yeah. So instead, what they've done is use this formula, but this was not discussed, right? So what trend is it following? So
I mean, I like to share something here, because if like one of I mean, as a tutor, we do also have another tutor, right? So who discusses, I mean, who generally discuss all the solutions. I mean, likewise you. So it was the very near deadline, and I had no idea like how to solve this, because in Google there will be lots of options, because it's again it's an abundance, you cannot go for it. And I clearly asked him about this question. If not, I mean, I can understand he cannot help me with this same values, but definitely with the other ones, I mean, giving in an example, then the guy was like, I do not know, sorry, I can't help.
Okay. Yeah.
Like, wow.
Difficult to find material on statistical moments. There's a lot about physical moments in physics online.
Yeah.
I'm not able to get the reference books also, which are mentioned. There are 2 reference books mentioned in the course description. I'm not able to get those reference books. Any chance there's any material that can help us go along the course that can be shared? Though if that reference book is available, nothing like it. But I looked all over the internet. I cannot download that reference book from anywhere.
Okay.
There is
Let
only
me
one
check.
place where I found it, and I keep clicking on download, and it just doesn't download.
Okay, fine. I'll check into that.
Okay.
And I'll put it on the discussion forum if I find anything. Okay. All right. Next question. So we are finding something is getting formed in these cells which are growing on a rigid substance, and the size is there. So what is the maximum percentage of these points lying 2 standard deviations away from the mean? Now, the thing is, so in this question, so you have these points available with you. You can find the standard deviation and you can find the mean. Now, you remember we discussed this in 2 perspectives. One wherein we discussed it for Chebyshev's, and the other we saw it in terms of specifically in terms of normal distribution, right? So now, so this 95 number that has been given here, this is actually applicable for a normal distribution, not the general Chebyshev's, right? Can you tell what was the number for Chebyshev? It's 70, 75. What is it? It's not 95, right? 2 standard deviations away from the mean.
3/4, ma'am, for 2 standard deviation, 1/4, 4 minus 1, 3/4.
Yeah, so 75. Right. So as such, it's 75 for Chebyshev's. Now, so I would like you to not pay attention to this line here, because this one's only applicable to normal distribution. Hello? Yeah.
Innovation sir.
Hello.
By 10 minutes to wait.
Maybe you can mute the person.
Okay. Yeah. I'll just mute all of you. I think it's done. Just unmute yourselves in case. Yeah. You can unmute yourselves now to discuss. Yeah. Okay. So the idea here, so basically what you can do in this case is, once you have found out, and then you can see, okay, the mean is 3, the standard deviation is 0.6. So what we are looking at is 1.2 less than and 1.2 greater than. So which is 1.8 and 4.2, right? So these ones. And if you see all your observations, all of them are lying within this range, right? So, so since it's 100%, the closest number is 95. But again, this 95 number here is not from Chebyshev's, but it's, and so the maximum percentage is not the, I mean, it's not the most appropriate terminology used, right? So Chebyshev's is like the minimum percentage, so 75 is minimum. For this data set, it's 100. For a normal distribution, they say it's at least it's 95%. So, but yeah, right? So I'll just inquire why is 95 the most appropriate answer? All right. Okay. Right, then the average pH
Ma'am,
is, yeah.
I'm sorry, I never understood only how you arrived at that.
The 95 value, right?
Yeah.
Yeah. So what we're looking at is either 100 for this data set, or we are looking at 75, which is like the minimum number when we are talking about Chebyshev's theorem. 95 is the number you get for a normal distribution. But that's not mentioned anywhere here. So why is 95 the correct answer? We'll have to ask. Yeah.
But okay, let's forget about this. How do you find it now? If you had to do it, how would you find a value that is 2 standard deviations away?
You just count. So you got this range, right? You found the mean, that's 3. You find the standard deviation, you are seeing here 2 standard deviations away. So you have 3 minus 1.2, which is 1.8. You have 3 plus 1.2, which is 4.2. So you're counting how many values are there between 1.8 and 4.2. So for this data sets, it's everything. 100%.
So you
Yeah.
calculate that for the sampler population.
Say that again.
So here you divided for the standard deviation, divided that 3.9. So there, if we
10,
if we
11.
take that,
Yeah.
so based on that, we'll get 90 or 95. Both values we get 90% and then 95.
Oh, okay.
So here you divided the 3.9 by 11, and the chance of dividing with the 10 also. And in that
Good
case, the
point.
samples will be between the 90 and 95.
Okay, fine. So yeah, so here also we'll just ask population and sample. So everywhere that standard deviation is being calculated, it's
So based on the formulas and based on the concept, everywhere we'll get 2 options.
yes. So it's worth confirming. Yeah, we'll do that.
ma'am, another thing, if we get such question in exam, then we have 3 options to solve this. One is by getting the range of standard deviation from the mean. Another one is if by plotting the curve, that if it is normal distribution, then this will be the thing. And if it does not work, then there's Chebyshev's theorem.
Yeah.
Which will be the most perfect, because all the 3 will not be possible to do it in that time.
Yeah.
So will you prefer to do that in that way?
Okay.
How it is derived here.
Right. Yeah. Good point. So when Chebyshev's is going to be used is when you don't have these points available. So Chebyshev's is just a theorem, right? Let's say when you are given the mean and when you're given the standard deviation, just like that, you're said for a data set with mean 3 and standard deviation 0.6, what percentage of what is the range in which you will have, let's say 75% of your data, at least 75% of your data. Then you can say, okay, 3 minus 1.2 and 3 plus 1.2. But when you are given these data points, you have the option of finding this range and then actually counting. So in that case, I would recommend you actually count. And yes, plotting is also a good idea, but it may not be possible to get a normal distribution from such few data points.
Yes.
You may
that is the
or
challenge.
you may not. Yeah. So for such a thing, I would have if let's say if these options were not given, so I would have proceeded to actually count and I would have said 100%. Yeah.
Okay, ma'am. Thank you.
Yes, but of course we will confirm all of this. Okay. Next question. So the average pH of urine is 6, the standard deviation, so the mean and standard deviations are given, and you have given one data point as 5. So you want to find the Z score and you comment whether it's an outlier or not. So when you find the Z score, which is the observation minus the mean divided by the standard deviation, you get a Z score which is less than 3, right? So yeah, right? So it's not an outlier. And okay, so 100 women were screened for breast cancer. Given below are the ages. Calculate the value for the third quartile in the interquartile range. So again, whenever you're talking about quartiles and medians, the first step is to arrange it in ascending or descending order. And you have 15 observations in this case. So you want to find Q3 first. So for 15, you will, you just add a number. So 16 and you take the 3/4 position. So which is 12 in this case. So 51. And find the IQR, you also need to find Q1, which is the value at the 1/4 position. So 1/4 of 16 in this case, that's 4th position, which is 37. So IQR is not median, right? So somebody had asked this on the discussion forum. Q1 and Q3, these are position-based values. IQR is not. So Q1, quartile 1 is Q1. Quartile 2 is actually your median, right? The second quartile out of 4. So that's median, and quartile 3 is Q3. These are position-based values. So you find the position and then you see what value lies in that position. And IQR is just a difference of these two values. So 51 minus 37, that's 14. Right? So you're asked Q3 and IQR in this case. So you have 51 and 14 as the answer. And then we have this question. So the weight of the babies of the same age and sex born at a hospital are given. A baby weighs this much. What weight percentile does this fall in? So now this is sort of in the, so percentiles were briefly discussed in the week when we talked about quartiles. So quartiles mean you're dividing it in groups of 4, and percentile means you're dividing it in groups of in 100 groups. So where does it lie? Which point does it lie in? Right? So it's up to you if you would want me to also ask about this question to the instructor, right? So
I don't have any doubts in this. I just have one problem. How does this 0.5 come? So whenever I'm solving this, supposing I get 5.25, and where the current 0.5 is, I will put 0.25, 5.25. So I'll put 0.25 and then I'll get the right answer. Supposing it is 6.75, if I put 0.75, I'll get the right answer. But I don't know why I'm doing that, or why has it been done also in the lecture has not been explained.
Can you say that again? I did not follow.
See, the formula for this is Pi is equal to I divided by 100 into n plus 1. Okay, so I
This
is
one?
any number, the formula for percentile and quartile in general.
Yeah, okay.
So I is any number. So supposing you want the say the 25th percentile. So I is 25 divided by 100 into n plus 1. So there are say 8 values. So it is 8 plus 1. And then you arrive at something. And then that number, from that number, say let's say you arrive at the value 3. So that the value on the third position is your percentile, right? Now you have to calculate. Now when you go down, where is that gone? Yeah. So supposing it is not you arrive in between. Okay. It's not, you arrive at say 3.67. So now you have to take the third value plus this something in decimal. The fourth value minus the, in brackets, the fourth value minus the third value.
Yeah.
Okay. I'm asking about that particular thing. How do you get this decimal thing, and what is the logic behind it? Where does it come from?
Okay, fine. So this is where we are talking. Yeah, sorry.
Sorry, yeah. So I'll just I got the 70, but I did it in a very simple way. I just arranged in the ascending order.
Yeah.
And since they are asking for the baby's weight less than 3.65, so I looked into the numbers, how many numbers are, weights are less than that. So which I got is 7/10. Okay, and into 100, then simple 70%.
Yeah. So, right. So this part, I don't think this was discussed in the course, right?
Not at all.
He does it
It
directly.
wasn't discussed. It was directly shown on the screen.
He puts directly 0.25 and 0.75.
Yeah.
But
So,
my question is, how does that how do you decide what value comes there?
Okay. Right. So let's say now in this case, there are 15 observations. So adding one is okay. Now let's say this last observation was not there. Okay. So we have 14. Now, so 14 plus 1, that's 15. And now we need to find quartile 1 and quartile 3. So that means we are doing 3 by 4 into 15. Right? So,
quartile 1 by 4, quartile 3 by 4. Correct.
Right. So let's say we are calculating for quartile 3 and we are doing it only for these numbers. Let's say this last number 62 was not there. Right. So now we do, let me open it here. So we have 15 into 3 divided by 4.
11.25.
11.25, right? That means we have this
so
one.
the value, the position of that value is somewhere between 11 and 12.
Yes, 1, 2,
That
3,
is what
4,
we've
5,
determined
6, 7, 8, 9, 10, 11, 12. So it's somewhere between this. So now what you do is, since it's 11.25, so now what you need to do is, so 11th position is this.
So
now,
50.
So you're basically, what you're doing is, let's say 50 and 51, you're zoomed into this on the number line, and you are taking like the 25th value there. You have 100 values between it, and you're finding the 25th value there. So it's 50.25. Right?
No. See, you arrived at 11.25. Now, according to what was taught to us is 50 plus 0.25 brackets 51 minus 50.
Yeah.
Okay. And when you solve this, you get, that is 1.
0.25.
You get, so you'll arrive at 50.25. Okay.
So here,
Why
here
0.25? How did the 0.25 come?
Excuse me.
So, yes.
0.25 means again that is 1 by 4th. So 11th
Yes.
value plus 1 by 4th, and that 11th value minus 12th value.
No. So, are we all clear until where 11.25 came? Since this formula was there, right? So Q3 means we want to find the value at the 11.25 position. Fine. So let me go to this thing here. Now, so at the 11th position, we have 50. Now let's say at the 12th position, let's just make it a little complicated, and let's say it was 53. All right. Now we want to, so this is a difference of 1. Now we want to find the 25th position here. The 0.25.
75th position. We took
11.25,
quarter
right?
3, right? We took third quartile, right?
We took the third quartile and it's coming to 11.25.
Right.
So 11.25 is the position we want.
Is the location where the value of the 75th quartile falls.
Yes. So 11.25. This is 11.25.
Okay.
Right? So now what we are doing here is, we want to find, so if it's 50 and 53, what would be the value? So if you just imagine this to be a number line, right? So it's imagine it like, if it's 1, you have a difference of 3. So I'm just using unitary method. Between 11 and 12, it's a difference of 1 in terms of position. So in terms of values, I have a difference of 3. Now, between 11 and 11.25, so if it's 0.25, how much would the difference be? 3 by 1 into 0.25, right? So it's point, so this would be 0.75 in this case. Now, in the particular question that we were talking about, the values were 50 and 51. So sorry. This is 51, right? So this is our 11th position and this is the 12th position. Right? Now we want the 11.25 position. So now, since it's in equal length, I'm just saying that by unitary method, this will also amount to 25. Right?
See, I get your point. We can easily arrive at it. It is not difficult. But I'm asking how does the formula arrive? Because today these are simple values. Tomorrow they are large data sets. They are complicated values. This 50 plus 0.25 into 51 minus 50. This whole equation that gives me this formula. In this formula, where does 0.25 come from?
0.25 comes from this value. This.
Okay, but what is the rationale of taking this value?
So you are finding so this is all quartile based. So if you have like in multiples of 4, you can easily divide it in groups of 4, right? You have 16 values. So 0 to 4, or rather 1 to 4, from 4 to 8, 8 to 12, 12 to 16. Right? But now if you have 13 values.
So in the video classes, Sir explained that, for example, here it is 11.25.
Yeah.
So it is 11.5 and it is 11.75. So in case of 11.5, sort of that 11th value plus 1 by 2 of that 11th value and minus 12th value.
That is in case of 11.5. That is in case of 11.5.
And in case of 11.75, took that 11th value plus 3 by 4th of 11th value minus 12th value.
12th minus 11th.
12th minus.
Yeah. And in case of 11.25, we have to take the 11th value plus and 1 by 4th of 11th value minus 12th value.
12 minus 11th. Yes.
Then we will get to 0.25 value between that any two numbers.
Yes. So you are just zooming into it. So you want, so like you said, so why, so when you have 16 values or when you had 15 and you add 1, so you get 16. So you are taking the 4th value. You already have a number at the 4th value, right? I mean, 4th value is it's a whole number. So you have a value. But when you're saying it's 3.5 or in this case 11.25, you don't directly have a value at 11.25. So you're making a value at 11.25. And how do you make? You're assuming this step between 11 and 12 and you're just, so as to say, you're interpolating in it.
We are finding the value which is present at the 75th percentile. So there are 75 values that are equal or below that. Correct?
Yes.
Why do you take 1/4 in that? So let's take this example only. 50 plus 1/4 of 51 minus 50. Now our intention is to find the value that is at the 75th percentile of this data set. Right?
75th is
Why
this.
do you take 1/4? Right. Why do you take 1/4 there when you do 50 plus 1/4 by into
because
minus
the 11.25 in that case would be, it's not the average of 50 and 51. It's slightly towards 50. 11.25th position, right? You're making a value here. It's not in the center of this. It's just the formulas.
But why not? Why 1/4? Why not say 3/4?
No. This is the value. It's not about 1/4 and 3/4. It's about 0.25. It would, if it was.
Okay. Let's say if this was 11.75.
Then you would have taken 3 by 5 into 51 minus 50. If it was 11.6, then you would have taken 6 by 10 into 51 minus 50. Right?
Not following. How do you arrive at that?
Okay. So what we are doing here is, let me.
Let's say you had 11.8, or so you take.
I'll take a different number. Mm,
11.8 is exactly the position that 75 or the third
yes,
quartile is situating.
yes,
That
yes,
is
yes.
why you were taking that number,
Right.
okay, between that range.
And
Mm,
for that number, we are using that exact position plus either it may be 0.25 or 0.5 or 0.75, what we told, it may be 0.8, or it may be 0.9.
yes,
And that value into, and we are subtracting the two values.
yes, yes,
And then we are
yes.
getting that exact value.
Yeah.
It may be not only 2.5, 0.25,
It
may
can
be
be
0.5,
anything.
it may be any value between
Any
the
value.
1 to 9, or it may be 10. If it is exactly 11, we'll get that, we'll take that 11th value. That indicating the position. And for the calculation of that position, we are taking this extrapolations.
Yeah. Right. Thank you all so much for the explanation. So all of you understood this, right? Right.
Okay.
So about quartiles and percentiles and medians, we first point out the position. So what we did for median, we took the center position. So let's say we had even number of observations. So we identified that this position holds our median. Now, in this case, we identified 11.25 as the position holding our value, but we do not have a value at 11.25. So what we do, we make a value at 11.25. How do we make a value? We just say that, okay, we are assuming it's a straight line between 50 and 51. And we are saying what should come at 0.25 of it. So we are just picking
Madam,
on that.
a small request.
Mm.
So till now in this third week, up to third week, this assignment 1 and 2 discussion of completion.
Yeah.
And in the last 2 weeks, we just discussed about the previously asked questions in assignments. So instead of it, could you please, in the practice sessions, could you please share the questions from that, what they mentioned, the reference books?
Practice questions from the reference books.
Yeah.
What is the, but like
And,
today we discussed a few practice questions, right?
If you compare the previous assignment questions and this assignment 1 and assignment 2 present course assignments, so the question difficulty is more.
Yeah, but there's no guarantee that if I ask from the assignment in the reference books.
Instead of previous assignment questions, previous assignment questions which were covered in the earlier courses. So could you please share the questions for the practice purpose from the reference books, what they mentioned in the course? Then we'll try to solve that.
Okay, I can try. Let me
Instead of
see.
practicing easy questions, if we go with the tough
Yeah,
question
but
practicing,
there's no
definitely it is helpful
guarantee
to the.
if I choose some questions from the reference, they will be easier or difficult, right? Because I mean
As one of the participants were told, we are unable to download that books also. So in that case, if you share that questions in the practice session, so definitely we'll try to solve that. Anyhow, that assignment questions which were.
See, but the thing is, the assignment questions, they are turning out to be difficult because somehow there's a slight mismatch between what is being taught and what is being asked, right?
Actually, it is not that much difficulty, but that concepts are not covered in that.
Exactly. So it's not about asking difficult or simpler questions. As long as you're clear with the concept, you can't have any very complicated questions coming up because relatively these are straightforward concepts, right? We're not going into a lot of ifs and buts in this, right? So give it another week or two with the same order while we make sure that the question and the assignments match with what is taught. If after 1 or 2 weeks you still feel that we need to increase the difficulty of the practice question, then I'll do that. Will that be okay? I'll keep this in mind. I'll try to add a few questions, but I will recommend let's first try and sort this confusion of the mismatch, right? And then we can go into one step difficult. Yeah.
Yeah, thank you.
Yeah. Okay. Thank you all for all your suggestions today. This was more like a brainstorming and clarifying session. Okay, so just concluding. So yeah, so the deadline is for next Wednesday, and I'll add up this PPT and that we discussed, and the recording will also be there on YouTube. So yeah, I think we're done with the session today. So anything else? Anybody?
Hello.
Yes.
I wanted to ask one question related to correlation of coefficient. It's not in the assignments, but it was a query when I was trying to apply it in my real life.
Okay.
Like I have 70 data points regarding 2 tests, and
Okay.
I want to find the correlation between the 2.
Okay.
So I can directly apply coefficient of correlation, or whether I have to find कि वो data linear है या मतलब
Yes, yes. So the only correlation coefficient that we discussed in these lectures, the formula that we saw was, it's called Pearson's correlation coefficient. So that is only for linear data. So you try plotting X and Y axis on the X and Y axis, you try plotting your data. If you see it's a straight line, then you use this formula. Otherwise, there are other correlation coefficients also. I am forgetting the name. There are a couple of more. Spearman is one of them, and there's one more correlation coefficient. I can just say Kendall's. Yeah, that's the other one. Spearman and Kendall. These are different ones. They have a different formula. So
if I try to find this correlation on R, what formula will it apply?
Which of the three?
Depending upon.
So you have the option. So if you go into the function, I think it's COR is the function, COR. So if you do like a question mark COR, you'll see that somewhere you can provide which method to use: Pearson, Kendall, Spearman. So Pearson's is for linear and the other two are for non-linear.
Ma'am, it means that after seeing the graph, how it is propagating, on the basis of that, we have to use the correlation equation.
Yes.
Okay.
Because the one that we saw, the formula, that's only for linear variables that are linearly dependent on each other. So when you can fit a straight line, but when it's like a different, some curve, when it's not a linear correlation, then a different concept is used. Something about when you arranging both the data in ascending order, how many of them retain the same order, something like that. But let's not go into it. But yeah, that needs to be taken into care of. That needs to be taken care of. Yeah.
Okay.
All right. Okay. So that's it for today. It's been more than 2 hours. So thank you for
thank you so much.
I will convey these questions. So I hope it's covered before the deadline for week 3, so that just in case any more changes are to be done in the week 3's assignment. But yeah. All right. Thank you. Bye-bye. Good night.
Yeah, thank you.
Thank you.